In this video, we're going to cover section 8.1, which is two variable linear systems or systems of two equations. So, if you have two equations and two unknowns, you'll have an x and a y, and your constants are real numbers, and then x, y are your variables. Three different answers you can have. You can have where the lines intersect, so the slopes are different. The name of the system of equations is consistent and independent, and there's only one solution. The other one is the lines coincide, so it's the same slope, same intercepts. They're consistent and dependent, and then there's infinitely many solutions. And then the lines are parallel, and so they have same slope, different intercepts. It's called inconsistent, and it's no solution. So we are going to solve this system by graphing. There's three different ways to solve: graphing, substitution, and elimination, and I'll show you all three of them today. So when you're solving by graphing, the best thing to do is set these both equal to y equals. So I'm going to say 3y equals negative x plus 1 divided by 3, so y equals negative 1/3 x plus 1/3. And so then if I want to plug in some numbers, let's pick -2, 1, -5, and 4. So if you plug in -2, you're going to get a 1. If you plug in 1, you're going to get 0. If you plug in -5, you're going to get 2. And 4, you're going to get -1. If you don't believe me, plug them in on your calculator. Just plug them in for x and you'll get out a y. And then the next one, this equation here, we're going to solve for y as well. So we're going to have 2y equals x plus 4. So y equals 1/2 x plus 2. I'm not going to make a table for this one because this one's a little bit easier to graph, just because my y-intercept's not a fraction. So I'm going to graph that one without doing a table. There's my line, and then we'll do another line in green for this one. So -2, 1, 1, 0, -5, 2, nope, let's undo that. See if I can get it any better. Let's zoom in a little bit. Well, you're getting the point. This point right here is the intersection point of the two lines, and that point is, we'll go back to 2, I guess I should take off I should make it 2, 1, -2, 1 is my answer. Next, we are going to do elimination. So you're going to choose a variable to eliminate. You're going to make sure it'll eliminate nicely when you add them or subtract them. And then you're going to use algebra to solve for whatever variable we have left, and then plug it back in to find the other variable. Alright, so if you have 0 equals 0, that means the lines are the same, or you have infinitely many solutions. If you have 0 equals a number, that means they're parallel and you have no solution. Okay, so we are going to solve this. We want to, since this right here is negative already, and this one's positive, I can multiply this bottom one by 4 to get it to go away. So 3x plus 4y equals 3, and then 8x minus 4y equals 52. And then add them together. Those are going to go away. You're going to have 11x equals 55. So x equals 5. So now that I know what x is, I can either plug it back into either one of those equations. I'm going to pick the top one just because it's easier. Actually, I'm going to pick the bottom one. Sorry. because I want to find y. So y is already by itself. So 2 times 5 minus y equals 13. So negative y equals 3. So y is negative 3. So your solution is an ordered pair 5, negative 3. This one, I need to figure out, I'm going to multiply the fractions by something, the decimals by something to get them to eliminate. And we're going to do 9. So I'm going to multiply this by negative 5. So I get negative 9x minus 6y equals negative 20. And then 9x plus 6y equals 3. So I'm going to add them together. Those go away and those go away. So I have 0 equals negative 17. And if we look back up here, it says when 0 equals a number, there's no solution. Fractions, your favorite. So I want to, let's say we want to eliminate the x's, just because it's easiest. Alright, so we're going to multiply this thing by something to get a negative 4. So I'm going to need it negative, and then it's going to be 6. So I'm going to have negative 4x minus y equals negative 4. And then 4x plus y equals 4. Well, everything goes away, so I have 0 equals 0. And if we go back up here, when 0 equals 0, that means we have infinite solutions. And last but not least, elimination problem. So I'm going to take and try to eliminate the x's here. So I'm going to multiply this top equation by negative 2. When I do that, I get negative 2 times x minus 1 over 2 plus negative 2 times y plus 2 over 3 equals negative 8. And I simplify, I get negative 1x minus 1 plus negative 2, this one doesn't simplify, over 3 equals negative 8. And then I'm going to distribute, so I get negative x plus 1 plus negative 2 thirds y minus 4 thirds equals negative 8. And then I'm going to combine like terms. So I'm going to have negative x. Let's write that so you can actually read it. Negative x minus 2 thirds y minus 1 third equals negative 8. That should be an 8. 8. And I'm going to take that and add it to x minus 2y equals 5. So my x's go away, and I'm left with negative 8 thirds y minus a third equals negative 3. So what I can do here is get rid of those fractions and multiply everything by 3. So then I have negative 8y minus 1 equals negative 9. So then I get, when I solve for y, I get y equals 1. So now that I know y is 1, I'm going to use this second equation here and plug in 1. X minus 2 times 1 equals 5. So x minus 2 equals 5. So x is 7. So my solution is 7, 7, 1. And then we need to solve each system using the substitution method. Substitution, you're going to solve for one variable and then plug it back in. Well, this one's already solved for us. So I'm going to plug it in for x. So 2 times 3 minus 1, 3y minus 1 minus 3y equals 7. Distribute 6y minus 2 minus 3y equals 7. So 3y minus 2 equals 7. So y is 3. So now that I have y, I'm going to plug that back into this equation here. So I'm going to have x equals 3 times 3 minus 1. So x equals 8. So my solution is 8, 8, 3. And then this one I need to solve for a variable. I'm going to pick the first one and solve for x. So when I do that, I'm going to solve this one for x and get x equals 2/3 y plus 1/3. And then I'm going to plug it in for x, so -7 times 2/3 y plus 1/3. It doesn't matter what variable you're solving for. Plus 3y equals 1. You can just pick one. And then I get -14 thirds y plus minus 7 thirds plus 3y equals 1. And then I'm going to take and combine my y's, so I get -5 thirds y minus 7 thirds equals 1. And if you want, you can multiply everything by 3. That's 1. So that gives me -5y minus 7 equals 3. My handwriting has gotten worse as we've gone. Equals 3. So then I'm going to solve for y. So y ends up in being -2. And so now I'm going to plug it back into an equation. It doesn't matter which one. I'm going to pick the first one. So 3x minus 2 times -2 equals 1. And simplifying, 3x plus 4 equals 1. So x equals -1. So my solution is -1, -2. We're not going to do 5. We're just going to do number 4. So finding the point of equilibrium equals the point price P and the number of units x satisfy both the demand and supply equations. So you're going to set d of x equal to s of x, and then you're going to solve for x. And then you're going to find P by plugging it in. So here's my equations. I'm not going to read them to you just because I know you can read. So I'm going to say 100 minus 0.05x equals 25 plus 0.1x. So I'm going to solve for x. So 75 equals 0.15x. So x equals 500. And then plug in 500. So 25, I just picked one of them. You don't have to plug it into both of them, you just pick one. And you get 75. So your ordered pair, if you wanted to graph these, would be right here.